Okay, so in this part, we will talk about problems, or we will solve problems in which the mechanical energy is conserved dahil internal force ang gumagawa ng work on the object. When we say conserve yung mechanical energy, that means the TME initial is equal to the final. So remember our equation, di ba? We had TMEI plus work done by the external force equals to the TME final. Pero since internal energy yung gumagawa ng work, mawawala na siya, di ba? Yung work done by the external force. What the internal force is doing is just transforming the KE to PE or vice versa. So dito makita mo talaga na equal lang yung TME and TMEI and TME final. The sum of the kinetic and the potential is the same all throughout. Okay. So I think na illustrate din natin, no? But just to be clear, for example, ito yung skier mo, di ba? For example, dito siya nagmula, so meron siyang salida para maakyat yung sunod na mas maliit na na hill, di ba? So at this point, pinakamabilis siya. It is at its fastest or at his fastest. Kasi as it is falling down the decline, nag-increase yung kanyang speed. So that's why much bigger. The key is actually greatest here. And virtually zero potential energy. But then, as it is ascending this smaller hill, hinihila siya pababa ng gravity, di ba? So nababawasan yung kanyang speed. However, yung kanyang potential energy ay yun naman yung nag-i-increase. Okay, so the kinetic energy now will be transformed to potential energy kasi tataas yung kanyang position from the ground. Meanwhile, kapag bumaba na ulit siya, so he is again at the highest level right there. So malaki ulit yung PE, virtually 0 KE. Pero pag bumaba siya, again, mag-increase yung speed niya habang mabagsak. And then, on the final, maliit naman yung PE. Kasi, nasa ground na siya. Okay? So, that means na yung potential energy mo was transformed to kinetic energy. Meanwhile, yung kinetic energy mo dito ay na-spent sa pag-akyat ng hill and na-transform siya into potential energy. Both sides of the equation are equal kasi conserve ang mechanical energy. Okay, another example ng object in which the mechanical energy is conserved ay itong pendulum motion. Baka i-argue mo po na, sir, may tensional force, so that means may external force, di ba? Pero remember, laging perpendicular yung direction ng tensional force dun sa direction ng motion. That means magsi-zero kasi FD cosine 90 degrees, this will be 0. So it's not doing any work. Diba? For example, let me draw the trajectory of this pendulum. So if this is the tensional force, here is the displacement. Okay? That means na perpendicular sila. If nandito na yung linya, here is the tensional force, here is the displacement. So at all points, it is perpendicular to the direction of the motion. That means it's not doing any work on the pendulum ball. What's doing work on the ball, on the pendulum bob, is, of course, gravitational force, diba? So, kung dito yung starting position, dito mo i-release yung pendulum. That means that point is highest, diba? In terms of distance from the zero height position. So, parabolic yung, or pa-arco, yung gagawin yung, diba, motion. At this point, pinakamababa yung kanyang potential energy. And then, again, diba, aakyat siya dito. Kung saan, change siya. Marireturn niya na yung original height niya. And then, babalik na siya doon to position A, to point A. So, at this point, PE is highest, di ba? But it will gradually be transformed to kinetic energy kasi as the gravity pulls it down, sa point na to, dito naman highest yung KE, di ba? And then, habang umakit siya, lumilit yung KE hanggang ma-reach niya ulit yung pinakamataas na or magkaroon ulit ng pinakamataas na potential energy. Zero naman yung KE sa mga point na ito. Here and here. Remember na there's a point kung saan titigil, di ba? Yung pendulum bob. Kasi babalik na siya doon sa kasi nabuo na niya yung cycle niya. Kung baga, babalik na siya doon sa kanan or doon sa kaliwa. Mag-swing na siya doon sa kabilang part. That means na nag-zero yung speed mo doon. So, zero yung kinetic energy on that part. But that's also the part na pinakamataas na na-reach niya. That means na, although zero yung KE, pero yung PE, that's the highest. Is highest at those points. Okay, let's look at this. So, at point 1, position 1, your PE is 6 joules, but 0 joules kinetic energy. Zero kasi yung velocity mo doon, di ba? Same with position 4. Now, we will be asked to solve for the height and the velocity at different points. Okay, so for A, we have to solve for the height. Remember, that's PE mgh. So H1 for height 1. So 6 joules. Oh, what's the mass? Okay, 2 kilogram. The mass of the bob is 2 kilogram. So 2 kilogram, 9.8 meter per second squared times the height 1. So 2 times 9.8, that's 19.6. That would be in Newton. Times height 1. Oh, it should be 1, not I. Height 1 equals 6 joules. We will divide both sides by 19.6. Okay. 6 divided 19.6 is height 1 is 0.31 meters. Is that correct? 0.31, or to be exact, 306. Okay. At 2 pala, magpapantay yung PE and KE mo. But still, that result to a 6 joules total mechanical energy. Let's solve for the KE. KE, 2 1/2 mv2 squared. Position 2. KE is 3 joules, 1/2. Mass is 2 kilogram. Okay. So this will be 1 kilogram. 1/2 times 2. Okay, divide both sides by 1 kilogram. So, matirang ka ng meter squared, second squared. Square root. Square root of 3 is 1.73 meter per second. Is that correct? Yes. 1.73 meter per second. Meanwhile, okay, to compute for the height, you should compute for the height, you can do it. But the answer would be 0.153 meters. Okay, now, potential energy is 0 kasi nasa 0 height position siya. So, that would mean na the height is, 0. Now, I assume that you will be able to compute for the E. And the E should be 2.45. And then the F will be, okay, illustration. So 0.306 meters. Same nung sa A. Okay. Syempre roller coaster, diba? If you remember, yung sa Enchanted Kingdom, hilahin mo na pataas yung train, diba? And then kapag na-reach na yung maximum height, release na ng clamp yung train. And gravitational force alone will power, diba, itong train car. aakyat sa mga loop, liliko siya, and so on and so on. Hanggang marating yung sunod na, na height, na incline sa dulo. Tapos, babagsak pa orong hanggang marating yung the spot where sasakay yung mga passenger ng roller coaster. So, the same thing as the skier, di ba? At this point, low yung KE kasi it's not moving at all or it's moving slow. Pero nasa pinakamataas na height siya. That's why highest yung potential energy doon. But we can treat this one as the zero height position, di ba? So, ito yung pinakamababang point. Potential energy is minimum here while pinakamabilis. Nag-accumulate yung speed niya habang wabagsak, di ba? And then, okay. Compared with this one, sobrang taas ito, di ba? This is just a small hill. That's why your potential energy is lower compared with the kinetic energy. So, mabilis pa rin siya dyan. Remember, it's just a small hill. Okay? But at all points, yung sum ng KE and PE is the same. Constant or conserve yung mechanical energy mo. Okay? Dito 40 joules yung 40 joules yung total mechanical energy at all points. Okay. So this one, 0 ang KE, highest ang potential energy. Notice that interestingly, no, as it should be, pag mataas yung height nung mga loops or the hills, palit yung potential energy mo doon, of course. Kasi mas mababa siya sa ground. And so on. Okay. Indicate what type of forces are doing work upon the ball. Indicate whether the energy of the ball is conserved and explain why. Finally, fill in the blanks for the 2 kilogram ball. Dalawang case ito, di ba? Una, yung ball, duman siya dun sa mga staircase. And pangalawang case, nahulog siya. So, here, at the top, potential energy is 100 joules and 0 joules. So, what are the forces acting on the ball? So, let's assume that friction is negligible. So, syempre, ang kapabagsak sa kanya dyan ay gravitational force. That's an internal force. So, the energy of the ball should be conserved. The total energy should be conserved. Now, with that information, here is 50 joules. So, the KE should also be 50 joules. Okay. So, since no friction, the ball will keep doing what it's doing, diba? First law. 50 joules. Nasa same same level. And then, at this one, this is the zero height position. Expect that the potential energy will be 0. Nag-flip na yung situation. This is 100 joules KE. Okay, now it would be easier to compute for the V. I mean, you already know how, diba? 50 joules, 1/2, 2 kilogram V squared. Again, this will be 1 kilogram V squared. 50 joules. Divide both sides by 1 kilogram. So 50 meters squared, second squared, V squared. 25. That's so neat. 25 meter per second. Okay. Okay, wait. That was a mistake. 50 square root of 50 is 7.07. Rather, I'm sorry. I got carried away. 7.07 meter per second. Okay. So also, right here, should be 7.07 meter per second. Pag 100 joules ang kanyang speed, okay, computin nyo na lang but the velocity should be 10 meter per second. So, if babagsak na lang siya dito, hindi niya dadaanan yun, syempre nasa ground, so 0. And then, the KE is highest here, so 50 joules, 100 joules rather. 100, 10 meter per second as well. Please do the computation. Okay. Let's skip this one. Using the law of conservation of energy, fill in the blanks at the various marked position for a 1,000 kilogram roller coaster. Okay, this is the same problem, diba? Okay. In the zero height position, PE will be zero. Virtually all of the energy is in the form of kinetic energy. Here, PE is 200,000. So, subtract that. So, 250,000 joules ang KE mo dito. So, anyways, the height you should be computing here should be 45.9 meters. Velocity here, so since KE is 0, there's no speed, hindi pa siya umaandar. Sa letter D, you should be computing 20.4 meters, while here is 22.4 meter per second. And at the zero height position, which is H, 31.6 meter per second. Okay, I hope you'll be able to compute it. Good luck. This is the last part. I'll see you there.